Hello YouTube fam. Welcome back to our channel. In this channel, we will be discussing various topics in the exciting world of AI, machine learning, and computer vision. Our content is crafted by our awesome human team, but here's the magic. It's finely tuned and optimized by our AI wizards, bringing you top-notch information. And guess what? The presentation is delivered to you by our AI hosts and voiced by our incredible AI avatars. Let's get started. In today's video, we will look at Fine Tuning Ultralytics YOLO for human pose detection with help from Roboflow. We will use it to determine if the person is standing or if they have fallen down. This could be useful for medical situations. In step 1, we will generate human pose images using DAL. We will create images of person standing and of person fallen down. In step 2, we will convert downloaded images to JPEG. In step 3, we will upload images to Roboflow. Roboflow is a company that provides tools for building, deploying, and managing computer vision models. It offers services such as dataset management, annotation tools, and model training and deployment support. Roboflow aims to streamline the workflow for developers and researchers working on computer vision projects, making it easier to create and scale machine learning models for image and video analysis tasks. We will do manual annotation. We will add labels and add bounding boxes. We will add key point skeleton. We will add points for head and toe. Finally, we will train Ultralytics YOLO model. Ultralytics is a company that specializes in developing state-of-the-art machine learning models and software, particularly for computer vision tasks. They are best known for creating the YOLO, You Only Look Once series of real-time object detection models, which are widely used in various applications such as autonomous driving, surveillance, and medical imaging. Ultralytics provides tools and frameworks to help developers build and deploy efficient and high-performing computer vision solutions. In the end, we will use the finely tuned model for prediction on test images. We will use it to determine if the person is standing or if they have fallen down. We will find the angle between head and toe. For a person who is standing, the angle is around 80 to 90 degrees. If the angle is below a certain threshold, we will say the person has fallen down. This could be useful for medical situations. We thank Roboflow and their writers like James Gallagher, especially the Roboflow blog. Launch, label, train, deploy support for key point detection models in Roboflow. Roboflow blog, we thank Ultralytics for the model. In step 1, we will generate person standing and fallen images using DAL-E. Sample prompts used. Create image of a person fallen down and lying horizontally. The picture should be taken from the ground level and side view, not from the top. Both head and toe should be visible. Create a realistic picture of a person standing. It should cover from head to toe. Orientation should be vertical. The orientation should be vertical, and person should also be vertical. It should show the face with facial features as well, and it should show the toe as well. In step 2, we will convert downloaded images to JPEG. We will do from PL import image. We will then do img.convert RGB. In step 3, we will upload images to Roboflow. We will do manual annotation. We will add labels and bounding boxes. We will do most important part for key point annotation. We will add key point skeleton and specify head and toe. We will then split images to train, test, valid data sets. In step 4, we will install packages. In step 5, we will download dataset from Roboflow. Remember to set up API keys. In step 6, we will train Ultralytics YOLO model. We will use Ultralytics YOLO VN pose model. We will call the model train function. We will provide data YAML and tune for 40 epochs. It will take a few minutes on T4 GPU. In step 7, we will run prediction on the test images. We will set model path to the best weights. We will run the prediction by passing the image to the model. The results contain the classes, bounding boxes and key points for head and toe. We will then draw the image using Pillow. We can see the bounding box around the person. We can also see the key points for head and toe in light blue and dark blue colors. Next up, we will find the angle between head and toe. For a person who is standing, the angle is around 80 to 90 degrees. If the angle is below a certain threshold, we will say the person has fallen down. For this sample, the angle is 10, and we are predicting that the person has fallen down. We scroll down the notebook and look at prediction for a few more images. For another sample, the person is standing, and the angle is 77, and we are predicting that the person is standing. In step 8, we will run prediction on video. We will set model path to the best weights. We will read video file using cv2.video capture. We will get video properties. We will run YOLO model on the frame. We will check the angle between the predicted key points. We will find the angle between head and toe. For a person who is standing, the angle is around 80 to 90 degrees. If the angle is below a certain threshold, we will say the person has fallen down. We will convert the output video to a compatible format using FFmpeg. All right, finally, let us look at the video and the prediction. For the first few frames, the model is predicting that the person is standing. This seems correct. For the last set of frames, the model is predicting that the person has fallen down. This seems correct. That is it, folks. We have looked at Fine Tuning Ultralytics YOLO for human pose detection with help from Roboflow. We used it to determine if the person is standing or if they have fallen down. This could be useful for medical situations. Thanks for watching. Stay tuned for more exciting adventures in the world of AI and machine learning and algorithms. If you found this video helpful, don't forget to hit that like button. Subscribe for more tech talks and ring that notification bell to stay updated on our future explorations. Until next time, happy coding and keep the curiosity alive. Thanks for watching.